Today we're going to be solving another LeetCode coding exercise. This is going to be an interesting one to find a fast solution for. And I'm also going to talk a little bit about the thought process behind coming up with the solutions for these sorts of problems. But first, thanks to Mailgun for sponsoring this video. Mailgun is how modern companies work with email. Mailgun is easy to use, has amazing 24/7 customer support, and simple but powerful APIs that smart developers can use to reach their customers at scale so their organizations can grow faster. You can use Mailgun's API to send an email with just a few lines of code with whatever language you're using, of course, including Java. It really couldn't be easier. Today, Mailgun is used by over 100,000 companies and top brands around the world to provide personal, connected experiences through email and drive smart results. You can send and track transactional and marketing messages, remove invalid emails from your list, or prevent fake signups in the first place easily. Mailgun also has an awesome send time optimization feature that automatically finds the perfect time to send to each and every individual on your list at the exact time that they're most likely to engage. They also have a team of email experts ready to work with you to improve your email deliverability and also drive higher conversion rates. With its intuitive email marketing solutions and powerful API, Mailgun works through the whole email lifecycle, from pre-development all the way to the inbox, for more than 240 billion emails a year for companies like Wikipedia, DHL, Toast, Lyft, and Microsoft, helping them solve complex communication problems and build connected experiences through email. So thanks again to Mailgun for sponsoring this video. Try Mailgun today by using my link, which you can find down in the description, mailgun.com/John. Now let's get to it. So this is LeetCode problem number 3, and it's a medium difficulty problem. And it's called longest substring without repeating characters. So basically, we're going to be given some string, we'll call it S, and our task will be to find the length of the longest substring within that string that doesn't repeat any characters. So they've got a few examples here. So if our input string is ABC, ABC, BB, well, the longest substring within this string that doesn't repeat any characters is just ABC. So if we were looking through this string, we would go, okay, A, B, C. All right, we haven't repeated any characters yet, and so far we've got a substring length of 3. But if we were to try and add the next character, well, that's an A, and we already have an A, so that's not a valid solution. So the longest substring without repeating characters in this example is ABC, and that has a length of 3, and so our output would be 3. One thing to note about this example is that technically the solution could have been BCA also, or CAB. Those are also substrings that don't repeat any characters. But they also just have a max length of 3 anyway, so it doesn't change what our output is. Still, the longest substring that doesn't repeat any characters in this string is just 3. So if we scroll down to the bottom here, we can see that we have a couple of constraints on the string input that we're going to receive. So one thing is that it'll only consist of English letters, digits, symbols, and spaces. That just means there's nothing really crazy for us to deal with as far as the characters go. And it also says that the length of our string is going to be greater than or equal to 0, so we won't have a negative number of characters in our string. And the length of the string will be less than or equal to 5 times 10 to the 4th. Okay, LeetCode, you're trying to be real fancy there with the scientific notation. This is just 50,000. 10 to the 4th is 10,000. Times 5 is 50,000. And that really shouldn't be big enough to cause any sort of problem with any kind of solution that we might come up with as far as memory goes or anything like that. So let's start thinking about the solution for this problem. So with a lot of these LeetCode problems, there's often like a brute force solution that most people come up with first. And then often there's a more clever answer that's a little bit more tricky to come up with, but leads to a much more efficient and fast solution. Now the same thing is the case here. So to start, let's look at an example string that we might be given and talk about what our brute force solution to this problem will look like. Basically, we're just going to loop through every single possible substring of this string until each of those substrings repeats a character, and then keep a running maximum of the largest substring that we find that doesn't repeat any characters. That might sound a little bit confusing, so let's just walk through a quick example of what it's going to look like. So what we'll do is start by looking at all the substrings of this string that start with the first letter, A. Of course, just the letter A by itself has no repeating characters. So as of right now, the maximum substring that we found that doesn't repeat any characters is of length 1. And then we say, okay, we haven't run into any repeating characters yet. Let's add the next character to our substring. And the next character is B. So now our substring that we're looking at is AB. And so we say, okay, we're adding B. Does B already exist anywhere in our substring? No, it doesn't. So there's still no repeating characters. So now the maximum substring that we found that doesn't repeat any characters is of length 2. Next, we go ahead and add the C to our substring. Does C already exist anywhere in our substring? No. So we still don't have any repeating characters in this substring. So our new maximum is 3. So next we look at the next character, which is A. Does A already exist in our substring? Yes, it does. So now this substring contains repeating characters, and so it doesn't count as a valid substring that we're looking for. So now that we've run into a substring that has a repeating character, we know that the largest substring that starts with this first A that doesn't repeat any characters is just ABC, that has a length of 3. So next we have to look at all the substrings that start with the second letter of our string, B. B by itself doesn't contain any repeating characters, but it's only of length 1, which is not greater than 3, so our maximum is still 3. And then we move this over to include C. BC also doesn't contain any repeating characters, but it only has a length of 2, so it's not bigger than the maximum we already have. So we move over and look at BCA. It also doesn't have any repeating characters, but just has a length of 3, so there's no need to change our maximum. And then when we move this over to include B, now we have repeating characters, and this isn't a valid substring anymore. So then we move the beginning of the substring that we're looking at over to the C and do the same thing all over again. So that would eventually get to CAB with no repeating characters, which is still just a length of 3. And then when we add on the next C, it now has a repeating character. But then we will move on to starting with this A. And this can proceed all the way to the end of our string without repeating any characters. A, B, C, D has a length of 4 and doesn't repeat any characters. So when our program sees that, it will update this maximum to 4. And then it'll loop through all the rest of these characters in exactly the same way, but it won't find any non-repeating substring that's any longer than 4, which is this A, B, C, D. And so we'll find that the solution is 4. So next, let's go ahead and copy this over to IntelliJ so we can do our coding there. And let's get to implementing that brute force algorithm. So first, a good thing to have is just going to be an int variable, a max length, that we're going to use to keep the maximum length of the non-repeating substring that we've identified. So we'll eventually return that as our solution, and we'll initialize it to 0. Next, we're going to want a loop that will look through each individual character of our input string and use each character as the start of the substring that we're looking at. And we'll just keep that simple and use a for loop. This will be a pretty simple for loop. So for int I equals 0, we're going to keep looping while I is less than s.length. And each iteration through the loop, we're going to increment I. But now, nested within that, as we're looping through each character in our string, being the start of each substring that we want to look at, we then have to have an inner loop that adds on each subsequent character to our substring and keeps doing that and adding characters until we find one that repeats. So in order to do that, we're actually going to need a nested for loop within this one. For int j, we'll call it, and we'll actually start it not at 0, but we'll initialize it to I, because we don't necessarily want to start our inner loop at the very beginning of the entire string. We want to start it at the beginning of the substring that we're looking at, and that will always start with the ith character. We will still loop while j is less than s.length. We'll go to the end of the string with our inner loop as well, and in the inner loop we will increment j each time. But actually, just within our outer loop, we want to create something that we can use to build our substring, something that for each iteration of our inner loop we can add to in order to build the substring that starts with a certain character. Now there's a bunch of potential ways you could do this, but one decent way is with a string builder. Now string builder, if you've never used it before, is kind of what the name of it says. It's an object that you can use to build strings, and often we'll use it in situations like this where we want to add to a string in iterations through a loop. So here we'll create a string builder and call it, let's say, current substring. We'll just initialize it to a new string builder. So now what we're going to do is, in each iteration of this inner for loop, we're going to be adding each subsequent character to the substring that we're building. And along the way, as we're building the substrings, as long as the current substring we are looking at doesn't have any repeated characters, we're going to be seeing if it exceeds our current max length. And if it does, we will update the max length to be the current large substring that we're looking at. And we're going to keep looping through, adding the next character to the substring that we're looking at until we find a repeated character. And then once we find a repeated character, we're going to break out of this inner for loop and then start looking at every substring that starts with the next character in the string. So for example, as the outer loop is looking at this first character, A, our inner loop is going to be looping through each subsequent character after that A, adding it to the substring that it's building, that string builder that we created, and it's going to do that until it adds a character that it identifies as being a repeat. And so when we do find a character that repeats like that, the outer loop is going to increment by 1, and we are going to start looking at all substrings that start with the next letter of our string. And then our inner for loop is going to do the same thing. It's going to use that string builder to add on each subsequent character in our string onto the string builder until it identifies a repeat character. So here's how we're going to implement that functionality into our inner for loop. First, we're going to check whether the next character that we're about to add on our substring already appears in our current substring. And if it does, well, we have a repeated character and we want to break out of our inner loop. To do that, we can say if. So what we'd like to do is take our current substring and see if it already contains the next character that we're about to add to it. But unfortunately, String Builder doesn't actually have a contains method that just returns a simple Boolean. So what we have to do is instead we have to call the index of method on it. So the next character that we would add to the substring is the character that's at the jth position in our original string. And so to get that, we can just call s.char at, and then pass in the index we're looking for, j. Now again, unfortunately, this index of method can't take a character. You have to pass in a string. But luckily, it's easy to convert a string to a character. All we have to do is call string.valueof and then pass in our character like this. So now what this index of call will return is it will return the position of this next character that we're about to add in the current substring if it already exists there. And if it doesn't already exist there, it'll return a -1. When it returns a -1, that's its way of telling us, I didn't find that character in this string builder. What that means is, if the index of this character is anything except for -1, that means that that character already exists in our substring and we have a repeated character. And as we said, once we find a repeated character, we want to break out of our inner for loop. So that is accounting for the situation where, we're adding more things to our substring, making sure there are no repeated characters. But then once we do that and we're about to add a character that would be a repeat, so in this situation, when we're about to add an A, but we already have an A, that would break out of our inner for loop, and then it would start looking for substrings that start with the next character in the original string. However, if it gets past this point, then we know that the next character that it's about to add is not already in the current substring that we're looking at. So in that case, great, let's go ahead and add it to the current substring that we're building. And to do that, we just call current substring.append, and we want to append that same character at the jth position of our string. So all this append method does is take the character that we're passing in and add it onto the end of our current substring. So now we know that the current substring that we're looking at doesn't have any repeated characters. So what we want to do is, if that current substring's length is greater than the current maximum length non-repeated substring that we found so far, then we want to set our max length to be the length of our current substring. Current substring.length. Kind of a cooler way to do this though, instead of having to, okay, let's check to see if the length is greater than the max length, and if it is, then we'll set the max length to be that one. That works just fine, but if you want to be really cool about it, instead you can do something like max length equals math.max, and then pass in as the two parameters the current max length and also the length of the current substring. And then you can get rid of this because this line of code is doing the exact same thing. This math.max method will just return whichever one of these two parameters is larger. So what that means is if the maximum length is already larger than the current substring's length, it'll just get set to that max length again. But if our current substring's length is larger, then it will set max length to be that instead. So it's just a little bit more of a concise way to do the same thing. So then after all of that, after it does all those loops through all the possible substrings and maintaining that maximum length of the non-repeated substring that it finds, at the very end of this method, we actually have to return that maximum length that we found. I think that should do it. Let's go ahead and copy the solution and paste it back over here into LeetCode and submit it and see what happens. Okay, here we go. All right, so we see that our program is successful. Awesome, right? Well, yes, but let's look at some of these facts here. So our runtime was 433 milliseconds, which says it's faster than 5.94% of all Java submissions for this problem. That's not great, right? That means that 94% of all Java submissions for this problem were faster, were more efficient than our solution. From the last LeetCode video, I heard that a lot of people struggled with techniques for coming up with a faster, more efficient solution to these sorts of problems. You know, what should I consider? What kind of things should I know? How should I even start thinking about it? So first, let's talk about why our current solution is probably so slow. So what we're doing in our solution is we're looping through each character in the string, and then within that loop, we're looping through each subsequent character in the string. So to do that, that meant that in our algorithm, we had to use a nested for loop to do that. So that means that the time complexity, the big O complexity of our algorithm, is going to be big O of n squared. Usually when you have in your algorithm a nested for loop that loops through your data set in both of those loops, usually that means that you have a quadratic time complexity, big O of n squared. So literally, like, the bigger that this string s is that gets put into our program, so as that s gets larger and larger, with just a little bit of increase to the size of our input, our program will take dramatically longer to run. So what we want to do to try and make this run faster is to, of course, just lower the time complexity of our solution. Now that could mean a couple of things. There could be various ways to do that, but the main thing in this situation, what we want to do is get rid of this inner for loop one way or another, if at all possible. So if we can accomplish our task just by looping through our string one time, then that's what we want to do. But then, of course, we have to think, well, how can we do that? There are a few things that you can keep in mind when you're trying to come up with that sort of a solution. A big part of what you want to keep in mind is just the different types of data structures that you have available to you. So that could be things like lists, queues, sets, maps, trees, and knowing how each of them work, what they're all useful for, and the properties of each of those helps you to know what could be helpful to use in various situations. But honestly, a lot of it is just doing a whole lot of these challenges, coming up with your own solutions, and when you struggle, look up what other people's solutions are and what they came up with. See which ones are faster and try and understand why. But for this specific problem, what do we need to do in order to be able to get the solution with one pass through our string? Well, we need to know the whole substring that we're looking at any given moment, but we also need some way to determine at each character in our loop whether that character already exists in our substring, but we want to do that without looping through all of the other characters in our substring, because then we'll be right back in the situation where we have that inner loop. Now, one way I can think to do that is with a hash map. And we actually did use a hash map in kind of a similar situation in the last LeetCode video. In this situation, we can use a hash map to remember the index that we last found each character that we run into in our string. So it'll be a map where the keys are the characters that we find in our string, and the value associated with each of those keys, with each of those characters, is going to be an integer that represents the last position that we encountered that character. Here's what I think we can do. Let's walk through an example. So in this case, we'll actually use 2 pointers. Well, don't worry, we're not going to use 2 for loops, but we are going to use 2 pointers, a left pointer and a right pointer. And we're going to start with both of those pointers pointing to the first character in our string. So right now our substring is just this single character A. We look at that character and we say, okay, does that character exist in our map yet? And of course our map is empty, we haven't done anything with it yet, so no it doesn't. So that tells us that there's no repeats in our current substring. So what we can do is we check the length of that substring, which happens to be just 1, there's just 1 character, and then we go ahead and set our max to 1. But then before we proceed, we add that character, we add that A to our map. So what we're saying in our map is, the last time I saw the letter A, it was at position 0. So A is the key in our map and 0 is the value. So what this means is, later if we encounter the letter A again, we can just look it up in our map and say, oh, the last time that an A appeared was at position 0. And then we don't have to loop through the entire string to find that out. We can just do a constant time lookup in our map. So that map is going to be the key here. The map is going to be how we're going to essentially get rid of our inner for loop and improve the time complexity of our algorithm. So after we add the A to our map, we then go to the next iteration of our loop. But we don't move the left pointer, we only move the right pointer. So that increments to the next character in our string. So what we do first is we look up B in our map. Does it exist in our map? No, it doesn't. So that's cool. That means we don't have any repeated characters. So we look at the length of our current substring, which is 2. So we can update our maximum substring length to be 2. And then we want to do the same thing we did before, and we want to add B to our map now. So we'll say, okay, the last time that we encountered the letter B, it was at index 1. And then we move to the next iteration of our loop, and the same thing goes for C. Is C in our map? No, it's not. So we update our maximum to 3, because that's the current length of our substring, and we add that to our map as well. The last time we saw C was at index 2. And then we move on to the next iteration of our loop, and we look up A in our map. Does A already exist in our map? Yes, it does. So that means, yes, we've seen it before. But another thing that we do want to check is, did we see it before inside the current substring that we're looking at? And we can know that pretty easily just by checking the index where we've seen it before. So in our map, we look up A and we say, oh, that A was last encountered at index 0. And we can see that judging by our left and right pointers, our left pointer is at position 0 and our right pointer is at position 3. And that means this A at index 0 is within our current substring. So because of that, we know that we definitely have a repeating character inside our current substring. So we have to fix that before we move on. We have to set our substring to be something that doesn't contain a repeating character. And we actually fix that by moving our left pointer. So this is the situation where we do move our left pointer. So we're looking at an A currently with our right pointer, and we can see, okay, the last time we saw an A was at index 0. So in order for our current substring to no longer contain that repeating character, we're going to move our left pointer to be 1 past where we last saw that letter. So we'll just do this. So now we've shifted that substring that we're looking at to where we now know that it no longer has that repeating character. Now before we move on, we still want to update our map, because now the last time that we encountered the character A was not at index 0, and now we last encountered it at index 3. Now, as before, we move on to the next iteration of our loop, which means moving the right pointer 1 character over. So now we're looking at the letter B, and we look that up in our map to see when we last encountered it. And we last encountered it at the index 1. And 1 is within our current substring also. So that means, okay, our current substring has repeating characters. And so what we want to do is move, again, our left pointer to 1 past where we last found that character. So our left pointer will move over here. And then again, same as before, we still have to update our map to show that the last time we encountered B was at index 4. Now in the next iteration of our loop, we're looking at the letter C. C does already exist in our map, and its index of 2 is within our current substring. So we want to move our left pointer to 1 past that to make sure there's not a duplicate, and update our map to show that the last time we encountered a C was at index 5. And then we'll iterate through our loop again for our right pointer to point to the letter D. Does D exist anywhere in our map? No, it does not. So we know that the current substring that's contained within our left and right pointers does not have any repeating characters. And it has a length of 4, which is bigger than our current max. So we can update our max to be 4. And it will go ahead and add that D to its map also. It'll say, okay, the last time we encountered a D was at index 6. But at that point, the right pointer has reached the end of our string, and so our loop finishes and our program finishes. And we get the solution that the maximum was 4. One thing to notice about this particular solution is that as it's going through the string, there's always a particular section, a particular window that we care about at any given time. And it kind of slides right and grows and shrinks as it processes the string. And there's actually a name for that kind of algorithm called a sliding window algorithm. That's why if you're looking up solutions for this problem, you'll see a lot of things about a sliding window algorithm. And also notice that even though we do have 2 pointers, we only have 1 loop through the string. And that makes this algorithm a linear time algorithm, or big O of n. And also, since we'll be using a hash map to do the lookups for the last time we encountered each character, those lookups will actually be in constant time. So they won't affect the linear time complexity of our algorithm. So now let's go ahead and implement this sliding window hash map algorithm and see how much faster it is. All right, so we're gonna get rid of a lot of this, but we are going to keep our max length variable declaration and our outer loop. We still need that. But we are going to change a couple of things about this loop to make our code a little bit easier to read with how our algorithm will now work. So instead of just calling this variable I, let's call it right, because it's going to represent the right pointer in our algorithm. So we'll change I to right in each of those places. And also, if we want, we can go ahead and declare our left pointer here also and have it start at index 0. But remember, we'll only be changing our left pointer if we find repeats while we're processing substring. We only want to increment the right pointer in every iteration of our loop. Now, remember, as a part of the solution, we need to have a map that will hold the last position that we saw each character. So let's create a map. And remember, this is going to be a map where the keys are characters and the values are integers. We'll call it, I don't know, visited characters. That's not my favorite name for a variable that I've ever come up with, but let me know if you have a better one in the comments. We're going to initialize that to a new hash map. So now inside our for loop, where we're looping that right pointer through the string, we want to check whether the character at that right pointer is already in our map. So we can do that with if visited characters dot contains key, and then passing in the character that's found at our right pointer. So that's just s.char at right. One thing to remember though is that even if we find the character that we're looking at is already in our map, it doesn't necessarily mean that that character is within the current substring that we're looking at. So once we find it in the map, we still have to check whether the index that we found it in the map is actually a part of our current substring. But luckily that's not too complicated to add. So we just want to add another condition to our if. So yes, we've already found that it's in the map, but we also want to get the index where we last encountered that character. So we'll get s.char at right. And we can know if it's a part of our current substring if the last place that we found it is greater than or equal to our left pointer. And if this whole condition is met, if the result of this whole thing is true, that means, yes, we saw this character before, and it's within our current substring. So our current substring has a repeated character. And remember, if that's the case, then we need to move our left pointer to be one past where that repeated character is. And we can do that just by setting our left pointer to be the position where we last encountered that character. So visited characters.get s.char@right, and we want it to be one more than that, so we get just past that repeated character. So we just add 1. Now, one thing I'm noticing as I'm writing this algorithm is that I'm using this s.char@right 3 times, and it's kind of starting to look a little verbose. So I think what I might do is create a variable for this. So I'll go ahead and create a char variable. We'll just call it current character, and we'll set it equal to that s.char@right. And then we'll go ahead and replace everywhere we're making that call with that variable. There we go. So now it's a little bit easier to read and also might perform just a little bit better because it doesn't have to do this lookup 3 different times. So at this point in the algorithm, we know that either the substring that we were looking at either didn't contain any repeat characters, so it didn't have to adjust the left pointer, or if it did contain repeat characters, it did adjust the left pointer so that it no longer has any repeated characters. So now what we can do is update our max length. And we can do that in the good old fancy way, again, by using math.max. And we'll take the maximum of either the current max length or the length of our current substring. And we can get the length of the current substring that we're looking at by using our left and right pointers. So what we can do is take right minus left and then add 1 to get the current length of our substring. Adding 1 might seem a little bit weird, but it makes sense if you think about it, because let's say right and left were both pointing to the same index. They were both pointing to an index of 0, the very first character. Well, that of course has a length of 1, but if you took 0 minus 0, you'd have 0, and that's not correct. So you have to add 1 to right minus left in order to get the correct length of the substring that you're looking at. Now, the only other thing that we have to do is we don't currently have anything that's actually putting the characters that we encounter onto the map. We still have to do that. So after all this processing, we want to put on the map, okay, here's the last place that I saw this current character. So we'll just call visited characters.put to put a thing on the map. And the key that we're putting on the map is going to be the current character. And then the value is going to be the position where we're encountering that current character. And that's just the right pointer. Okay, so after our for loop exits, we'll just return the max length. That doesn't change from our last algorithm. I think that should be it. So let's go ahead and copy this over, paste it into LeetCode, and we'll see if this is any faster. So here we go. Okay, so we have 12 milliseconds. So we went down from, what was it, 400 something milliseconds down to 12. That is a dramatic difference. It's a huge difference. And that's probably largely because the complexity of our algorithm went from quadratic to linear. And we also use quite a bit less memory, maybe less than half of the memory that we were using before. However, you might notice that it looks like there's still some room for improvement of our algorithm. Of course, we're way faster than what we were before, but we're only faster than about 2/3 of other entries. There are still plenty of entries that are faster than this one. So that was kind of bothering me that, 1/3 of solutions were faster than this one. So I was looking up other potential solutions, and one that I found that did end up being faster than this really caught my eye, and I wanted to share it. Now remember, back in our code, we're using this map of visited characters to look up when we last encountered a certain character. Now this other solution that ends up being faster is structured in a very similar way, except it doesn't use a map at all. And so of course, without that map, all this other code that uses that map doesn't really apply anymore. But then of course you might ask, okay, well, how are they doing that lookup to see when we last encountered the current character that we're looking at? And actually it's done in a very simple way. Let's just call it, this is an awful name, but location of first appearance in substring. So all they're doing with this is looking for the index of that current character that the right pointer is looking at. So s.char@right. But they're not searching through the entire string to see where that character first appeared. They have it start at the left pointer. And that makes sense, right? You only need to know if that character already existed just in your current substring, not in the entire string. And I guess a better name for this might be just index of first appearance in substring. Okay, so now we know where this particular character that we're now looking at first appears in the substring that we're looking at. And so all we have to do is say, okay, if that index, where that character is different from the right pointer, it exists somewhere already in the substring. Because of course it exists where the right pointer is pointing at right now, but if it appears any other time, then that means we now have a repeated character. And so if we do have a repeated character, we essentially do what we did in our other algorithm, which is just move the left pointer to be one past where that repeat character was found. So we'll set left to be the index of the first appearance in the substring plus 1. And other than that, the algorithm is all the same. We still set the max length the same way as we did before and return it at the end of the algorithm, and that's it. But let's go ahead and copy this and put it into LeetCode and see what our performance is like. Here we go. 5 milliseconds, and that's better than almost 95% of all Java submissions. So it's just about twice as fast as the other solution. And of course, if you submit this a few times, you do get a little bit of variability in the amount of time that it takes. So at that time, it took 4 milliseconds, better than 97.75% of all Java submissions. So that's really interesting. It was faster than our map-based solution. So that really got me wondering why that might be. And I'm interested what you all think in the comments of why this particular solution is faster than the map-based one. The reason I think that's interesting is because our map should give us a constant time lookup to see where that character last appeared in our substring. But the way that they have it doing the lookup here in this solution is it has to use an index of. And I believe index of just has to loop through each individual character in the particular substring that it's told to look at to see if that character exists anywhere in there. So I would think at a glance that that should give you a worse time complexity than the map solution. But it performs much faster, 2-3 times faster than the map solution. The only thing that I could think of is that even though the time complexity might not be as good technically as the map solution, perhaps given the particular strings that LeetCode uses to test the algorithms, it could be that just index of performs way better than maps do just for that particular input, even though the time complexity isn't as good. There are definitely situations in some algorithms where certain inputs could perform better on algorithms that technically have worse time complexity. So this could definitely be one of those situations. So even though I didn't come up with this particular solution, I wanted to share it because I thought it was so interesting. So as always, let me know what you think. If you like this video, learned something, want to see more things like this, let me know and give the video a thumbs up. And of course, if you're interested, go check out my full Java course, which you can find in the link down in the description. It's a great way that you can support the channel and get a ton of value and Java knowledge in return. So thank you all so much, as always, for watching, and I'll see you next time.